Timeless concepts from Physics Helpline. In this video tutorial, we will discuss two multiple choice questions taken from the NEET exam of 2019. The questions are as follows. Question 1. Read the question carefully. It is given that radius of the first permitted Bohr orbit for the electron in an hydrogen atom is equal to 0.53 angstroms and its ground state energy is equal to minus 13.6 electron volts. Now, if the electron is replaced by a muon, about which it is given that charge on the muon is same as that of the electron and its mass is equal to 207 times the mass of an electron. We are required to find the first Bohr radius and the ground state energy for the muon. The options are given in the question. We are required to find the correct option. First, let us understand the related concepts. Bohr's theory. Let us define the mass of the electron is equal to m, charge is equal to E, speed of the electron in orbit is equal to v, and radius of the orbit is equal to r. For circular motion, the necessary centripetal force in this case is provided by the electrostatic force of attraction between the nucleus and the electron. Therefore, we write mv square by r is equal to E square by 4 pi epsilon 0 r square, which gives mv square is equal to E square divided by 4 pi epsilon 0 r. And according to Bohr's postulate, angular momentum of an electron in orbit should be an integral multiple of h by 2 pi. Therefore, we write L is equal to mvr, which is equal to nh divided by 2 pi, which gives v is equal to nh divided by 2 pi mr. From equations 1 and 2, we get the following. What we do in equation 1, we have got mb square on the LHS. For b square, we will put the square of equation 2. b square will be equal to n square h square divided by 4 pi square m square r square. So we have put that m into n square h square divided by 4 pi square m square r square is equal to E square divided by 4 pi epsilon 0 into r. Therefore, we write on simplification r is equal to n square h square epsilon 0 divided by pi m E square. Therefore, we write this as the radius of the nth orbit. Rn is equal to n square h square epsilon 0 divided by pi m E square. Now, from equation 1, we have got half mb square on the LHS. Therefore, we can write kinetic energy Ek is equal to half of mb square, which is equal to E square divided by 8 pi epsilon 0 into r. And potential energy Ep is equal to minus 1 by 4 pi epsilon 0 into E square by r, which is equal to minus E square divided by 4 pi epsilon 0 r. Therefore, total energy E is equal to sum of kinetic energy and potential energy. We observe that the kinetic energy is half of the potential energy. Kinetic energy is positive and potential energy is negative. Therefore, the total energy E will be equal to minus E square divided by 8 pi epsilon 0 r. Now, from equation 4, we'll put the value of r here. From equation 3, Rn is equal to n square h square epsilon 0 divided by pi m E square. Putting that, we get En is equal to minus E square divided by 8 pi epsilon 0 into 1 by Rn will be equal to pi m E square divided by n square h square epsilon 0. On simplification, this gives En is equal to minus me fourth divided by 8n square h square epsilon 0 square. Now from equation 3 we get Rn is proportional to 1 by m, and En from equation 5 we get En is directly proportional to m. Now for the answer, it is given in the question that the first Bohr radius for the electron is equal to 0.53 angstroms and ground state energy is equal to minus 13.6 electron volts. For the muon, it is given that charge on the muon is equal to the same as that on the electron. Therefore, we write Q mu is equal to QE. Therefore, it is not significant. It doesn't come into the calculation because charge doesn't change when you change the particle. And it is given in the question that mass of the muon is equal to 207 times the mass of electron. Therefore, we get m mu divided by me is equal to 207. Therefore, since R is proportional to 1 by m, we get R mu is equal to me divided by m mu into Re. Now, me divided by m mu is equal to 1 by 207 multiplied by Re is equal to 0.53 angstroms. On simplification, this is equal to 2.56 into 10 to the power minus 3 angstroms. 1 angstrom is equal to 10 to the power minus 10 meters. Therefore, we get R mu is equal to 2.56 into 10 to the power minus 13 meters. Again, from equation 7 we get E is directly proportional to m. Therefore, E mu is equal to m mu divided by me into EE. Now, m mu divided by me is equal to 207 and EE, energy of the electron, is equal to minus 13.6 electron volts, which on simplification gives E mu is equal to minus 2815 electron volts, which is equal to minus 2.8 kilo electron volts. Therefore, we have R mu and E mu is equal to 2.56 into 10 to the power minus 13 meters and minus 2.8 keV, which is the answer to question 1. Therefore, the correct option is D. Now, for question 2, we are given that a proton and an alpha particle are accelerated from rest to the same kinetic energy. We are required to compare the de Broglie wavelengths lambda p and lambda alpha associated with the particles. The options are given in the question. We are required to find the correct option. Now for the answer. Let the mass of the particle is equal to m and velocity of the particle is equal to v. It could be the proton or the alpha particle. Therefore, momentum of the particle is given by P is equal to mv, and kinetic energy of the particle Ek is equal to half mv square. From equation 1, we get P square is equal to m square v square. Now, from half mv square, we get m square v square by multiplying by 2m. Therefore, we get P square is equal to m square v square, which is equal to 2MEK, which gives P is equal to root over 2MEK. Now, if the particle has got momentum p, then the de Broglie wavelength associated with it is given by lambda is equal to h by p, where h is the Planck's constant. Now putting the value of p from equation 3, we get lambda is equal to h divided by root over 2 MEK. It is given in the question that both particles are accelerated to the same kinetic energy, therefore Ek is not significant. Therefore we get lambda is proportional to 1 by root m. Therefore lambda p divided by lambda alpha, that is what we are required to find, will be equal to root over m alpha divided by mp. Now we know that mass of the alpha particle is equal to 4 times the mass of the proton, which gives m alpha divided by mp is equal to 4. Therefore lambda p divided by lambda alpha is equal to root over 4, which is equal to 2. Therefore we write lambda p is 2 lambda alpha is equal to 2:1, which is the answer to question 2. Therefore the correct option is B. This completes the answer to both the questions in this video tutorial. Thanks for watching. If the video is helpful, then please like, share and subscribe.